Alright guys, welcome to part 3. I've done a little bit of work, but this video will mainly just be me explaining what kind of analysis we're going to be doing. So before that, I can actually show you what changes I've made. So the last donor no longer has the summary. I instead exported it here. And we can look at the dictionary that we created earlier. It has basically everything. I needed this to kind of visualize what structure I made so I could remove the summary results from the last block of the context we had. And how we did that. So this segment comes from here. Our wanted segment, I create a global variable. It has nothing in it, however, and if I want to basically put whatever output I want into this global variable, because this is local, I have to declare it to be a global one. And then the way I did this was test py. I created this test file that would basically just parse it, and then I found it worked pretty well. So test py print parse. Oh, this is none because it's not actually doing it. Okay. Where are you? Okay. I think this should fix it. Yeah. So that was kind of the issue I was having earlier, where if I just returned, it wouldn't put the computation I want into the global variable. And the next thing I did was I created this small function to just delete the summary from the last block. So I got the content from the structure, and then I split it off from the first asterisk. So then the one before that is the data here. And it works now. It looks a little bit better. But I made a struct. I made a new template, which basically just makes this look like JSON. And if I wanted to change this, I can. It just looks better with 2 or 3. So okay. So the main idea of what we're doing now is, let's go to the first one. We have a donor ASP, AMC 34, and then the recipient Aroni BAQ 135. So we can see that these are the genes that are transferred from the donor to the recipient. And the key values we want is the actual gene family, because the gene families are transferred. And what we know is that if the donor transferred this family gene, let's name this D 211139814, the recipient will get this gene as such. And I believe this is called a in-order transfer. If the recipient was instead this, my roommate, I don't know if you can hear that, but he playing games. If it was like this, then it will be a reverse transfer. And if it was like this, for example, it would be just different. And we are going to basically provide further here more information on it. If it's in order, reverse, different, and then we could possibly show the gene sequence, the contigs. Contigs are just a slice of the gene. Because genes are too big, they are separated into contigs to make it more readable for everyone. Because otherwise they'll be super long. Okay, hopefully that makes sense. If there is something I missed, I'll include it in the next videos, but for now, I'll go into how we are going to do this. So we need the donor and the recipients. We are going to be finding the file inside the bigger Aeromonas dataset. I think the only folder we need are the genomes. The gene trees don't really pertain to what I want to focus on. And these are just a lot of random stuff that are important, but I think this is the actual like you know how in DNA there is like letters. I think this is this is actually it, but I'm not sure. So we would so manually doing this, we would copy and paste the donor and manually look at all this, stuff, which is not ideal, which is why I'm building this tool in the first place, so we can make this more readable and faster. Alright, and we do the same thing for the recipient as well. Plug it into the find filter, and I pinned it here just so I don't lose it. But so we basically want to find the gene family for 11134 in ASP. As you can see, it's ASP 11. Well, the 2758 is the gene name. So we want 2758, 2759, 2761. And we can find it basically here, 2758, 2759. Not this one, but this one. So we are going to have 11131, 21113, and 9814 for these ones. This is all going to be the same on every single one, I believe. Yeah, see, 15942 and then 162. But this is where we would want to come to. All right. Okay. Hopefully this is better. It's bigger now. So this is hard to read, right? It's hard to scan every single one. And it goes on for a long time. I think these are individual contigs. Yeah, contig 1, contig 10, all the way to a whole bunch of them. So all these mashed together is one strand of DNA, I believe. I'll correct myself if I'm wrong, but yeah, so it's long. So basically we would want to find this value, 1131. The one to the right of it is 485. That is not the direction we want. We want to go to the left. 2113, and then 9814. The gene names for the recipient is different than the donor, and also the gene number. So, what can we see about this? 1131, 21113, and 9814. This looks like what I drew earlier. The donor was 1131, 11131, 21113, 9814. And because because 9814, 2113, and 1131 happens, it is not in order. Wait, it is in order. It is in order. Okay. It is in order because 9814 comes first. And then, not this one. So we found out that this is in order. So for the next part, we would add it to this page saying it's in order, and then hopefully we can just pick out, oh, what happened? Hopefully we can just split these ones off from the rest of this file. Yeah. Okay. That's the direction we're heading towards. Hopefully I explained it all right and you guys understand, but I'll keep explaining it when I write the code and figure it out. Okay. See ya.